Assalamu alaikum, my dear students. Welcome to your chemistry class of standard 9. Hope all of you are fine and safe by the grace of Almighty Allah. Today I will take the class on these topics: heating curve, cooling curve, distillation process and sublimation process. So let's start the class. You know that the melting point of ice is 0 degree centigrade and the boiling point of water is 100 degree centigrade. Now you will know a new definition of latent heat. Follow here. The amount of heat that is absorbed or released by a matter to change the state, that is physical state of it without changing its temperature, is called latent heat. Latent heat, in Bengali we call it shupto tap. So what is latent heat? For example, if you keep some ice in a pot, then you will see it starts to melt, isn't it? But it will take some time to melt all ice and convert it into water, isn't it? So by this time it will actually absorb temperature from the atmosphere. So the amount of this absorbed heat from the surroundings by that ice molecules is called the latent heat of that ice. Or again, if you boil some water, then what will happen? At first some water starts to boil and it will take also some time to boil all the water molecules and convert it into water vapor, isn't it? So by this time the amount of heat which is absorbed by the water molecules to convert totally or completely into steam is called latent heat. I hope you understand. Now follow here. This is the heating curve. So heating curve, this is actually a curve where temperature is plotted against time. Follow here. This is the heating curve of water. Follow here. The below of the 0 degree centigrade, the water is actually exists in solid state, isn't it? So below 0 degree centigrade, here we will get the solid state of a substance or solid state of water, that is ice. Now at 0 degree centigrade ice starts to melt. So here this 0 degree actually melting temperature of ice. Now follow here. After passing some time, when all the ice molecules are converted into water, in this time temperature is not changed. It remains in 0 degree centigrade. So by this time actually ice molecules also still it absorbs heat from the surroundings and convert it completely into liquid water. This amount of heat is called latent heat. Now when all the ice molecules are converted into water, in that time again it will now presents in totally only liquid state and temperature is also increasing. Follow here. And when it reaches 100 degree centigrade temperature, then that liquid starts to boil. You know that 100 degree centigrade is the boiling temperature of liquid water. Now here liquid water starts to boil and now it will take again some time to convert all the water molecules into water vapor, and in this time also temperature is not changed. So this absorbed heat by the water molecules is known as latent heat. And when all the water molecules are converted into water vapor or steam, in that time again temperature is raised up. So this is the heating curve. Now more clearly, heating curve of water, follow here. Here I have mentioned temperature scale, and this is the heat absorbed, actually time. Now follow here. Here I have shown this is started from minus 40 degree centigrade, and minus 40 to 0 degree up to this portion, actually this is solid state of water, and this is melting. And now from 0 to 100 degree centigrade temperature, in this temperature actually water exists in liquid state, and above 100 degree centigrade the water exists in gaseous state, isn't it? So if we give marks or points of this corner, follow this figure, follow here. This is starting point. If we give A mark, then here B and C, then D, E, F, then it will explain easily like this way. Here AB, this portion AB, where temperature minus 40 to 0 degree centigrade is solid state of water, that is ice. Now BC, this state BC, this is actually mixture of what? Solid and liquid. That means ice and water coexist in this region, isn't it? Here temperature is 0 degree centigrade, but ice and water, they are coexist here. Now in C to D portion, in this portion C to D, here water completely exists in only liquid state, and temperature range is what? 0 to 100 degree centigrade. And at 100 degree centigrade, that is D to E portion, here we will see the mixture of liquid and gas. That means here liquid and gases, these two states coexist, and above 100 degree centigrade, that is E to F portion, this is totally in this state, in this region water is present, totally gaseous state. So I hope you understand. This is the heating curve. So when you will explain the curve, in that cases you have to draw this curve perfectly like this way. You have to give this mark, and you will explain like this way. So this is the heating curve of water. Follow here. This is the heating curve of sodium chloride. You know that the melting point of sodium chloride is 801 degree centigrade, and the boiling point of sodium chloride is 1465 degree centigrade temperature. So follow here, 0 to 801 degree centigrade, this A to B portion is for what? A to B portion is for what? This is the solid state of sodium chloride salt, isn't it? Now this 801 degree centigrade is actually its melting temperature, melting point. So at this temperature B to C point, this is the coexistence of solid and liquid state of sodium chloride. Now C to D, where temperature range is 801 to 1465 degree centigrade, this is the physical state is what? Only liquid state. That means this is the liquid state of sodium chloride. Now D to E, that is boiling temperature, and this is the boiling temperature of solid sodium chloride salt. This is 1465 degrees centigrade. So here the liquid and gaseous state of sodium chloride salt coexist, and above 1465 degrees centigrade we will get just sodium chloride vapor. So this is the heating curve of sodium chloride salt. Now we will know about condensation. In Bengali we call it ghoni bhaban. What is condensation? The process of transforming a gaseous matter into liquid by lowering temperature is called condensation. That is, this is the reverse process of what? This is the reverse process of, now we will come from gas to liquid. So, the transforming of a gaseous matter into liquid by lowering temperature. We know that in gaseous state temperature is highest. So, if we cool the gaseous substance, it will at first convert into its liquid state. So, this transformation is actually known as condensation. Follow here, at normal pressure, that is 1 atmospheric pressure, the temperature at which a gaseous matter turns into liquid state is called the condensation point of that gas. The condensation point of steam is 100 degrees centigrade. That means if we at 100 degrees centigrade, water is present in gaseous state, isn't it? And this is also the condensation point. Now, if you decrease the temperature at 100 degrees centigrade temperature, it also from gaseous it converts into liquid water, isn't it? So, the boiling point and condensation point of a particular matter is same. What is the meaning of this line? Boiling point and condensation point. Boiling point is what? Boiling point means conversion of liquid to gas, and condensation point means what? Condensation point means conversion of gas to liquid. And these 2 points actually are same point for a same matter is same. Why? For example, the water boils at 100 degrees centigrade into water vapor, and also water vapor condense at 100 degrees centigrade into liquid water. So, like this way, for every matter, boiling point and condensation point is always same for a specific matter. Now, freezing. Freezing is what? The process of transforming a liquid matter into solid by lowering temperature is called freezing. That means this is the transformation of liquid state to solid state due to cooling temperature. Follow here, at normal pressure, the temperature at which a liquid matter turns into solid state is the freezing point of that liquid. For example, the freezing point of water is 0 degree centigrade, and the melting point and freezing point of a particular matter is same. Melting point means the conversion of solid to liquid, and freezing point means the conversion of liquid to solid. So, these 2 temperature is also same for a specific matter. Now, follow here. Now, we will show cooling curve. Cooling curve for gaseous substance, isn't it? So, at first it will exist in gaseous state. Follow here, A to B, this is totally gaseous substance, and this B to C, this is actually coexistence of gas and liquid. And this temperature range, this 150 degree centigrade, suppose this temperature is actually the condensation temperature of this gas. Now, follow this curve, follow here. So, now condensation of this gas. Now, from C to D, in this case, they are totally liquid substance, liquid states of this substance. And now, in this range, this 100 degree centigrade, this range is actually freezing point of this substance, and in this temperature, the coexistence of solid and liquid state here, and E to F is totally solid state of this substance. So, this is the cooling curve of water. Follow here. Here AB is gaseous state, then BC is mixture of gas and liquid, then CD is liquid state, then DE mixture of liquid and solid, and EF is totally solid state. So, like this way you can also draw a cooling curve for a specific matter. Now, you will know about distillation process. In Bengali we call it paton prokriya, distillation process, paton. What is distillation process? The process of heating a liquid and turning it into gas is called evaporation or vaporization. Follow here, the process of heating a liquid and turning into gas. That means the conversion of liquid to gas. This conversion is known as evaporation or vaporization. And if we cool that vapor, the vapor turns into liquid. This process is called condensation. I have said previously the conversion of gas to liquid is known as condensation process. And these two processes combinedly called distillation process. Like this way, the process of heating a liquid into vapor and converting the vapor into liquid is called distillation process. That means distillation is actually the combination of vaporization and condensation. Follow this picture. This is the figure of distillation process. Follow here. At first we will heat the liquid water like this way, and at 100 degree, if it is water, then at 100 degree centigrade this liquid water turns into water vapor, isn't it? Follow here, this mouth is closed, so the water vapor goes where? Goes through this delivery tube, and this equipment is known as condenser. And condenser is what is the work of the condenser? It actually cooling the temperature, lowering the temperature. So when this water vapor goes through this delivery tube and enters into this condenser, then here temperature is decreasing, and due to cooling temperature this water vapor again turns into liquid, and follow here, this is dropped down as a liquid water. So at first here liquid converted into water vapor, and then water vapor due to cooling temperature or condensation again converted into liquid water. So this total process is known as distillation process. Now you will know about sublimation process. Sublimation process in Bengali we call it urdhopatan pranali. Urdhopatan pranali. So what is sublimation? The process in which a solid matter is directly converted into gaseous by heating without being liquid is called sublimation. That means some substances are there where directly converted into solid to gaseous, again gaseous to solid. So this process is known as sublimation process. The components that turn directly gaseous from solid without being liquid are called sublimated substances or sublime. For example, ammonium chloride, camphor, in Bengali we call it camphor, that means corpor, then naphthalene, you know, solid carbon dioxide, that is also called dry ice, iodine, aluminum chloride, etc. are actually the sublimes. That means among these you are very familiar to this substance, naphthalene. You have seen when you keep the naphthalene at open air, then its size is gradually decreasing, isn't it? Less. Why? Because at normal temperature this solid naphthalene actually directly converted into gaseous state. For this it converted into gaseous state and vanishes. Like this way naphthalene actually gradually vanishes if we kept it in open air. So here no liquid state we have shown. So this is the actually sublimes, and this process is known as sublimation process. Now we will know about heating curve and cooling curve of sublime. This is different from the previous heating curve and cooling curve, that is for water or sodium chloride salt. Why? Because in that cases we have seen there are three physical states, solid, liquid and gas, but here in case of sublimes we have seen only two physical states, solid and gas, isn't it? So its heating curve and cooling curve is also will be different, and it will be like this. Follow here. In first figure A to B, this is for only for solid, isn't it? And this is the what? This is the conversion temperature in where actually solid converted into what? Gaseous substance. So AB is totally solid, BC is the mixture of solid and gas, and CD is the gaseous state. I hope you understand. And this is the cooling curve. So if it is in gaseous state present of that sublime, then at first this state is only for gaseous, this is mixture of solid and gas, and this state is only for solid substance, solid sublimes. So these are the curves. So in the previous heating curve, cooling curve, we have seen there are actually three physical states. For this there is three steps are there, and here two steps, one step, two steps. So like this way you have to draw perfectly for the sublimes. You have to draw heating curve and cooling curve. Now you will know about the separation process, separation techniques of two or more substances by sublimation process. Follow here: separation of sodium chloride salt and ammonium chloride. This is also salt from their mixture. How can we separate them? By sublimation process. Follow here. Here we know that ammonium chloride is a sublime. So when the mixture is heated, ammonium chloride is evaporated and cooled down, isn't it? And sodium chloride remains at the dish. Follow this picture. Here in this china dish, we will take at first mixture of ammonium chloride salt and sodium chloride salt. Now this mixture of salts we will do what? We will keep a funnel in inclined position. We will keep a funnel over the salts mixture, and the open mouth of the funnel we will cover up using a cotton plug. Okay. Now this inverted funnel, and on this surface of the inverted funnel we will keep here some cooling ice or cooling cloths or cooling wool or cotton. That means here we will keep some cool cotton or cool cloths which actually lowering the temperature. Now what will happen when we will heat the mixture, salt mixture using burner, Bunsen burner or split lamp, then we will get after some time the ammonium chloride starts to converted into vapor, isn't it? This is the vapor of ammonium chloride, and when it reaches on this area, in that time there is used what? Ice, that is there is cooling the temperature by ice or water. In that time, due to cooling temperature, this vapor again, ammonium chloride vapor again converted into what? Solid, converted into solid state. So on the surface of the inner surface of the funnel we will get the solid ammonium chloride. Like this way all the ammonium chloride from these mixtures are converted into solid and gathered on the inner surface of the funnel. Now, and the only ammonium chlorides are rest at this china dish, because ammonium chloride is melting temperature is so high, 801 degree centigrade, which is not possible applied by this way. So like this way easily we can separate sodium chloride and ammonium chloride from their mixture. Now today up to this, I hope you understand my today's lecture properly. If you need, then you can watch this video class more times, and obviously we will read the book thoroughly and perfectly. So today up to this, staying safe, goodbye and thank you.